Alright, so here's the solutions to assignment number 4. You should do it first, right? And then follow. So let the function that's defined here. So we have a second derivative, a first derivative, and a function. And find each x so that the line tangent to the graph it is horizontal. So that's when the derivative is equal to 0. So first, I need to integrate the second derivative to find the first derivative. So we're going to add 1 to the exponent and divide. So that's going to be add 1 to the exponent. When you divide by 2, that's 12. Add 1, that's just x, and then plus c. Then we're going to plug this in. So we're going to make it equal to -6 and plug in 1. That's 12, take away 18. And that means c equals 0. So that means this, if c equals 0, that is your first derivative. And then find it so we have a horizontal. So we take this equal to 0. A horizontal line has a slope of 0. And then solve. So we're going to factor out 6x. That leaves me at 2x subtract 3. So when x equals 0 and positive 3 over 2, that's where the horizontal tangents are. So there's the answer to part A. Find f at x. So we're going to integrate this for f at x. So if I integrate the derivative, that gives me f at x. Again, I'm going to add 1 to the exponent. So that's x cubed. And then divide. And then 12 divided by 3 is 4. Add 1 to the exponent. Divide. That gives me 9. So 18 divided by 2 is 9. And then plus c again. Again, I'm going to plug in here. So I'm going to make it equal to 0. Do that here. And plug in 2. That gives me 32. Plug in 2. That's 36. That's -4. So add 4 and you get c is equal to 4. So if I put it together, this right here is that. So there's the function, f at x. We integrated, we plugged in the point. Average value is an integration question. I'm going to sneeze. Excuse me. Oh, you can't even see my face. Awful. All right. So we're going to integrate from 1 to 3. F at x, which we said is 4x cubed. And divided by the difference there, which is 2, so it's 1/2 in front. Again, we're going to add 1 to the exponent. 4 divided by 4 is 1. We're going to add 1 to the exponent. 9 divided by 3 is 3. And then 4x. And that's from 1 to 3. And then we're going to plug in 3 and plug in 1. And you have your answer. You don't have to simplify it. So there it is. All right, next question. Let f be this function. Find the domain of f. All right, the zeros of the bottom are -2 and 2. I get that. So -2 and +2 makes the bottom 0. I'm going to draw a number line to help me out here. If I plug in -3, I get a positive value overall. Because -3 squared is 9, and 9 take away 4 is 0. Positive value. Any number here between -2 and 2 is going to give me a negative answer. And any number bigger than 2 is going to give me a positive answer. This is my domain. So the domain goes from where it's positive. So from -infinity to -2, and from 2 to infinity. This is where it can't be. This is my domain. -infinity to -2, and 2 to infinity. Write an equation for the vertical asymptotes. That's what makes the bottom 0. So it's positive and negative 2. Write an equation for the horizontal. That's power term over power term. Now, the square root of x squared is x, but it could be positive or negative. So there's actually two. One's positive 1 and one's negative 1. And then find the derivative of this. So the derivative would be the quotient rule. So that's the bottom times the derivative of the top, which is 1, subtract the top, times the derivative of the bottom, has a hook of 2x, and then the bottom squared. And if you square a square root, it's just x squared take away 4. Next, you're given this function. Find the domain of this. Now you're allowed to use a calculator, so that's what I'm going to do. Oops. So I'm going to use my calculator to do it. Solve. Just type this in. So I typed in the calculator, solve this inequality. So I typed it in. If you press Control equal, you can get the inequality arrow. And it says true. That means for every single number, it's bigger than 0. So that means this is all real numbers. So x squared plus x plus 1 is always greater than 0. In this viewing window, sketch the graph of f. All right. Let's get rid of this from the other review. So first of all, let's just get the window right. So menu window, and it said for the x, from -5 to 5, and then this one was what, -3 to 3. So there's the window we want, and then the equation is (2x) over the square root of x squared plus x plus 1. All right, so there's the graph that I have. Looks like that. It has to show like a little minimum here. So it goes down and slightly up here. Write an equation for each horizontal asymptote of the graph. So again, 2x divided by the square root of x squared. So that's x. But it's positive and negative when, so one's positive 2 and the other one's negative 2. And then D, it says find the range of the function. Use the derivative to justify your note. So here's the derivative in terms of it. So the range is the greatest value to the smallest value. And so we already said that the intercepts, or this is 2 and this is -2. So there's a little dip here on the left side. So the range, the bottom value, I need to find where that minimum is using my calculator. So I'm going to move this. Then I'm going to go Menu, Analyze, Minimum. And see that y value, -2.309. That's the other side of it. So -2.309 and then 2 on the other side. So it goes low and then to high. It's kind of an awkward question. All right, turn the page. All right, these are calculator questions. Consider this curve defined by here. Find the derivative. So we're not going to use a calculator for that. We actually have to do some work here. So I'm going to do it down here below for 3a. So we have -16x. We have the product rule. The first, times the derivative of the second plus the second times the derivative of the first. The derivative, but it has y, so it needs a y prime, and then 0. And then we're going to factor out y prime from 5x and from 3y squared. I'm going to add 16x. I'm going to subtract 5y. And then I'm going to divide. Done. Part B, on what intervals, on part B, write an equation for the line tangent to the curve at 4, -1. So I'm going to plug in 4, -1. So I get 16 times 4 minus 5 times -1. So that's going to be plus 5. And then 5 times -1. 5 times 4, I mean. And then -1 squared is 1 times 3, that's 3. So I get 64. 69 over 23. Does that equal then 3? You can use your calculator, but I think it does come out evenly to 3. So that's the slope, right? That's what we're looking for. So the equation here would be y equals the point. So the slope is 3. The x coordinate is 4. And the y coordinate is -1. So there's the equation of the tangent line. Part C, there's a number k so that the point 4.2 and k is on the curve. Using the tangent line found in part B, approximate that value of k. So we're just going to plug 4.2 into the line. To find what k equals. This one. You can use a calculator, but that's minus 0.4, so just plug that in for x and then solve it. Part D, write an equation that can be solved to find the actual value of k so that the point 4.2 and k is on the curve. So plug in for x, plug in 4.2, and for y, plug in k into the equation, and we're going to solve it. So we're going to use this equation. We're going to keep x, but where there's a y, I'm going to plug in k. Where there's an x, I'm going to plug in 4.2, and where there's a y, I'm going to plug in k. And then we're going to use my calculator, your calculator. So we have 4.2 for x plus 5 times 4.2k for y, k cubed, and then equals negative 149. It's okay. Just type that in, solve it with your calculator. This is what it would look like. Menu algebra solve. So you have negative 8, 4.2 squared plus 5 times 4.2 times k plus k cubed equals negative 149, comma k. I get negative 0.372. Good. And you can see the approximate answer of negative 0.4, or the actual answer negative 3.72 is pretty close, right? The approximate one and the actual one. All right, part E, solve the equation. Oh, we did that, right? That's E. D and E together. So write an equation. I did it. And then solve it. I did it. Yay. One question left. I ran out of room. You probably should always do it on a separate piece of paper. I trust you however you want to do it. So we have a function defined as an integral from 0 to x. I feel like it's going to be the fundamental theorem of calculus question, but we'll see. From 0 to 3. That means that if you take the derivative and this cross out, and you just plug x in. All right. Use the trapezoidal rule with 4 equal subdivisions. So the width, if they're equal, on the interval 0 to 1. So that means the width of each one is going to be a quarter, because we have 4 equal subdivisions. And the setup, and I don't have to simplify this, it's 1/2, that's part of the formula, the width, which is there, and then I just need to understand it's going from 0 to 1, so it's going to be a quarter, a half, 3/4, and 1. So those are my subdivisions, 1, 2, 3, 4. So I'm first going to plug in 0. So 0 to 0. Oh, I'm approximately f at 1. So you plug in it, it's approximated from 0 to 1 of this. So to approximate this area, you're going to first plug in 0, and then you're going to double, and you're going to plug in 1/4 and square it. You know how you can do 1/16. Then you're going to plug in 1/2 and square it, and plug in 2 3/4 and square it. And then the last one is just sine 1. You don't double it, and it's done. So there's the trapezoidal rule. Part B, on what intervals is it increasing? So this is going to be that fundamental theorem of calculus. So the derivative, it tells me increasing or decreasing. So the derivative of this, they undo each other, and you just plug x in. So it's just sine x squared. And we're going to make it equal to 0 and solve it. Remember, it goes from 0 to 3. So we're going to solve this equation from 0 to 3. Let's use our calculator. It's probably even better to use your graph, because then you can see above and below with a graph. So I'm going to say graph. So again, I'm going to go menu, actions, and delete this. And then I'm going to go tab. I'm going to type in sine x squared. And I only want it from 0 to 3. So I'm going to go menu, window, and from 0 to 3, And then I'm just looking to see where, so notice here it goes above to below, so positive to negative. So I want to know what that value is. So I'm going to go menu, it's 0. So trace, analyze, and 0, number 1. What's that 0 right there? So I'm going to go left, then right, and that number is 1.772. All right, the next one, I'm going to do it again. I'm going to move this out of the way. So again, I'm going to go menu, analyze 0. I'm going to move it to the left and then the right so I can see again that next one of intersection. So that's 2.506. And 0 also gives me it. So if I draw a number line from 0 to 3 for the derivative, I have 1.772, 2.506, and I can say from 0 to here, it's above. So that's positive. So it saves us time above and below. The next part is below, so it's negative, and then the last part is above, so it's positive. And the question is, on what intervals is it increasing? So the answer is from 0 to 1.772 and 2.50623. So on those two intervals, it is increasing. This one, it is decreasing. All right, part C, last one. If the average rate of change, that's AROC, is K, find in terms of K. So the average rate of change from 1 to 3 would look like this. That's what average rate of change would look like. So I'm going to plug in 3. So I'm just going to use this equation, plug in 3. Calculator is going to do the work. Subtract, plug in 1. And then divided by 2. That's what K equals. And then I'm going to solve it. Now the question asks from 1 to 3, so I was looking it over. So if I find the area from 0 to 3, and then I subtract the area from 0 to 1, so if I subtract this area away from 0 to 1, what's left is 1 to 3 of what I'm looking for. So it's an awkward question, but it's good to think through it. And the question is, what is that? So we're going to solve for K and then multiply it times 2. So we're going to go menu, solve, algebra solve, and ultimately we're just going to multiply it times 2 right now, so that this is by itself. Menu, calculus, integrate. From 1 to 3. Sine t squared and then comma k. And you get 0.231. Oh, they didn't even say that. They just said in terms of k. So this is just equal to 2k. And if you would have solved it, it would have been 0.231. But they were just asking this. What does this equal in terms of k? And the answer is 2k. Again, a little clumsy, a little awkward, but you did it. And you practiced with me. I'm super proud of you. All right, Mr. G Math over and out. Your review's over.